notes on this podcast.
Yeah, awesome. So Kotlin has some great language features that lead to better productivity, better reliability. So just things like null safety being built into the language. Like I think that's kind of becoming an obvious default for programming languages these days.
I really hope so.
Yes. But that's something that leads to fewer production issues for people that are using it. And then language features like there's a nice DSL style way to use it's called Lambda with receiver pattern that leads to a nice looking DSL. If you in places where you want to have more of a DSL look to your code, then you can use language features to do that. Things like callbacks, there's a nice syntax for that, which when you're doing UI programming, callback style programming is an important piece. And so, yeah, being able to have kind of language support for that has been useful. Case classes to define your data objects has been, a feature that people really like. Coroutines is one of the big kind of headline features of Kotlin, which makes the async programming much more straightforward. So yeah, I think there's a type inference. There's a number of language features that just make it a good, modern, productive language. And then, of course, Kotlin coming out of JetBrains has a core focus of the language has been around IDE support. And so being able to have great IDE support that is continually evolving with the language has been important.
Persuade me over to this other IDE, to persuade me to the dark side. Let's talk about some of these language features and see what's good about them. So coroutines, I know you're excited about in Kotlin.
Yeah. So we often in a UI program or in the server side, you've got something async that you need to deal with, and that's oftentimes related to I/O. Right, you're firing off a request to a server, and then you don't want to block the thread while you're waiting for that to come back. Especially when you're on the UI, you don't want to block the main UI thread because then the user, their UI is no longer responsive. So
yeah, you don't want the button to freeze while you do an HTTP request, that kind of thing.
Exactly. Yeah. And on the server side, it's the most efficient way that you can use your resources in a system that has async IO calls is to not block those threads. And so definitely on the server side, it also is important to be non-blocking on IO. And so in the world of Kotlin, you can use coroutines to do this, and coroutines give you I'm sure many developers now are familiar with async await style syntax, where you can basically declare that this thing is async, and then in Kotlin underneath the covers that gets unrolled into the right like callbacks and non-blocking stuff that you need. But the programming model in Kotlin is nice. If you call something that is a suspend function, then you can on the next line of code use the result from what you get back, but underneath the covers it ends up being actually async. So it looks imperative, do this, but then it gets unrolled underneath the covers into the proper async constructs there. So, and the nice thing about coroutines is that it's a language feature with a supporting library, and so you can anywhere that Kotlin works, you can use coroutines. So Kotlin coming out of the Java JVM space, certainly you can do this on the JVM. There are some alternatives we can talk about on the JVM that are upcoming Loom, but the nice thing is that places where you maybe don't have that Loom style or Loom capabilities, like on Android, or there's now many other places where you can run Kotlin. You can now run Kotlin on iOS. You can run it on the web. You can build desktop applications with it. You can build CLIs with it. So any of those places now you can use coroutines. So you get one async construct that works on all the different platforms. So we'll talk about multi-platform in a minute because that's another interesting.
Oh yeah, we should definitely get onto that.
But yeah, the coroutines definitely a great programming model for doing async stuff. And it's I think now modern languages have I think generally embraced that style of programming for doing async stuff in some way or another. And so I there's two different sides of coroutines that are interesting. One is the request response style where you're calling an async function and get back the result, but it's async. But then there's the stream oriented construct as well, where it's called flow in coroutines, and flow gives you the streaming style syntax for being able to operate on a something that's not just a single result, but more than one result. And so you get both the stream and the function style approach to async.
And it handles both in the same mechanism kind of transparently, are you saying?
Yep. Yeah, exactly. Yeah. You do have a different API for the stream construct. So in coroutines, if you call a suspend function, then that's something that produces a single result. If you do want a stream, then you use the flow. And with flow, there's an API where you can emit things into the flow, or you can then read out of the flow. And so the Kafka, in the Kafka world, you use a flow to interact with Kafka. So you get a flow interface when you're reading from Kafka, or a flow interface when you're writing a Kafka. And so that's how you then interact with the stream-oriented approaches, is through the flow API.
Yeah. It's that difference between like grabbing a single row from a database and processing an ongoing stream of stuff. I often think that's quite nice distinction between HTTP and WebSockets, say.
Yes. Yep. Exactly.
And
that's
you want
a great
good
way to
ways
look
to
at it,
handle
request response or a stream of data. Yeah. And so you can also use a flow for a WebSocket, and so that's in WebSocket stuff that I've built, definitely will use that interface, and it's great because then you get one programming model for doing any stream oriented processing. So yeah, it's whether it's a WebSocket or Kafka or whatever, you use the flow interface for that.
That's cool.
So yeah, that's coroutines. Definitely one of the really important, valuable features of Kotlin is having that all kind of essentially built into the language.
So maybe we should talk just quickly, since we've mentioned WebSockets, HTTP, and Kafka. What's the library support like? Is it mostly go out to Java, or is it like plenty of native support for things?
Yeah, so there's, as usual in the JVM ecosystem, there's a lot of different options that you could go with. And so on the HTTP side, all of the major JVM HTTP libraries that are out there now have some Kotlin support in some way. And so Spring and Spring Boot is really the primary one in the JVM space. And so if you are in Spring and you want to do async stuff in Kotlin, you just use suspend functions and flows just like you normally would, and those integrate directly into how Spring then handles the reactive IO underneath the covers. And so for example, if you want to do a WebSocket, you can just do a flow in Spring, and that'll feed the data back. Kotlin does have a Kotlin native is the wrong word, but a Kotlin idiomatic HTTP library called Ktor, and similar to Spring, you can use Kotlin flows and suspend functions, and then all the other major JVM frameworks have Kotlin support as well, and coroutine support. So in the traditional JVM libraries, the Kotlin APIs are just wrapping the Java APIs, so there's some translation to what's happening under the covers in Java. But then in Ktor, you can plug in different engines, Netty, or they have their own native HTTP library called CIO, and so you can interchange the actual engine underneath the covers, but your programming model with using coroutines and flows is all the same, no matter what the actual underlying engine is.
Okay.
Yeah, so lots of different options for IO.
Okay.